Integration by substitution. Integration by substitution is the reverse chain rule. All right, without using the special chart I gave you. Some of them are on the chart, some of them are not. But if I have the integral of x plus 3 to the 5th power, dx, and I want to take the integral, we have the chain rule because we have the inside and we have the power. We use this. It's the integral of g of f of h, or f of x, times f prime of x dx, which we're just going to rewrite it as the integral of gu du. So you take the antiderivative of g plus c, and then we just substitute back in. I'll let you write it down, then I'll explain it a lot better the way it looks. All right, so here's the problem. We have the integral of x plus 3 to the 5th power dx. All I'm going to do is let u equal this. Now I'm going to take the derivative of this. What's the derivative of x plus 3 in respect to x? No, the derivative. Just 1. Because the derivative of this is nothing. The derivative of this is 1. So it's just dx. du equals dx. Not antiderivatives, derivatives. You go. Subtract 1. If I had, okay, what's the derivative of x squared? 2x. You bring the number up front, then subtract 1. It's the opposite of antiderivative. So this is what we have. We have the integral of u to the 5th du. All I did was substituted u for x plus 3. Now I take the antiderivative of this. Take the integral. 5u plus c. Yeah, to the, not to the 4th, to the 6th. Wait. You're mixing things up. You took the derivative. Antiderivative. When you take the integrals, it's antiderivative. So it's x to the 6th over 6. You're mixing them up. All I did was took u to the 5th, took the antiderivative. Now, what did u mean? X plus 3. Put it back in. X plus 3 to the 6th over 6 plus c. And that's the integral, or the antiderivative, of x plus 3 to the 5th dx. If I look on my chart, you said it was number 6? Yeah. If I look at number 6, x plus a to the nth. Well, it's x plus 3 to the 5th. All it becomes is x plus 3, the 5 becomes a 6 over 6. That was one of the shortcuts it was actually on that table. But not all of them will be written like that. No, that's not Jesus. That's the integral of 3x squared times the quantity of x cubed plus 5 to the 9th dx. What do you want to call u? What do you want to call u? In the parentheses. So I'm going to let u
plus 1 is... Ain't you just scared us? Well, I thought it was going to be 3x squared.
You can pick it whatever, but usually you're going to pick what's on the inside of parentheses. Can't make all of it you.
3x squared? Oh, come on, 3x squared.
If I had a 3x squared, that would be u, then this. Usually take what's inside of the parentheses. Make that u. What's the derivative of that? 3x squared. So if I take the derivative of that, du is 3x squared dx. So I'm going to replace this with u. So this right here becomes a u. I'm going to replace this with du. What do you notice you have in the problem still? 3x squared and the dx. So you're left with u to the 9th du. Du means 3x squared dx. Here's your 3x squared, here's your dx. Du means this. That's why we pick what's in the parentheses. The du will get rid of what's on the outside. The 9 is coming from this right here. All right? Now I take the antiderivative. What's the antiderivative of u to the 9th? U to the 10th over 10 plus c. Now I just put u back into the problem. So I have x cubed plus 5 to the 10th over 10 plus c. Let's look at this one. Here, let me rewrite this. If I take this, what's another way I can write that? If I have sine to the 4th of x, what does that really mean? No. Sine of x to the 4th. That 4 that was here can actually go to the outside. So what's really in parentheses there? Sine of x should be u. This right here should be u. What's the derivative of sine? Cosine. So I have the cosine of x dx. U replaces this. So I have u to the 4th. Du means cosine of x of dx. That's what this is over here. So du. Take the antiderivative. U to the 5th over 5 plus c. Substitute for the u. So it's the sine to the 5th x over 5 plus c. You can put it on the outside or put it on the inside. If you put it on the outside, you have to be careful, because if you write this, that's wrong. If you're going to do it, put it in parentheses or put the x in parentheses. Because there's a difference between sine of x to the fifth and sine of x to the fifth. We did this way, way, way long ago. Chapter 1 stuff. Try this one. What do you want to call u? Two x. That's good. Because that 2x gives me the problem. Because it was just x. This is 2x. This is different. Okay, what's the derivative of 2x? Two dx. Okay, I have the dx here, but I have a 1/2. I have a problem. So let's just find out what dx is. If I solve for dx, I need to divide by 2. 1/2 du is what dx is. Now I can replace dx with 1/2 du. Divide by 2 to just find out what dx is. So if I put in the substitution, 1/2 can stay there. It's a constant. Cosine of u, and then I have 1/2 du. Left the coefficient, stays out front. I replace the 2x with the u. I replace the dx with 1/2 du. I'm going to do a little bit of math here. This, we don't put the 1/2 here. We put it out front. So it's a 1/2 times a 1/2. 1/2 times a 1/2, 1/4. 1/4 cosine of u du. Take the integral. Take the antiderivative. Negative 1/4 sine of u plus c. Substitute back in my u. Negative 1/4 sine 2x plus c is my answer. Look at this one. I have the integral of x times the square root of 2x plus 1. I want to see if you can find out what u is and if you can figure out du. What do you think u is going to be? 2x plus 1. Now what's the derivative of 2x plus 1? 2 dx. Now what do I need to do? U to the 1/2 did I get rid of the x? All right, I have a typo. There's a typo. I forgot to put 2x squared. What's the derivative of 2x squared plus 1? 4x dx. Now, I have an x out here. What don't I have out there? I don't have that 4. So the x can stay there. Divide by 4. So it's 1/4 du is x dx. This right here will get rid of these two, and that's what you have to do. If you can't get rid of all the variables, you can't use substitution, or you did something wrong. So I have the integral. How can I rewrite it? Now it's just taking the u and the du and replacing. This is going to be 1/4. I'm just going to put u to the 1/2, the square root of u, du. If you do it correctly, there should be no x's left, but u's. No x's, no t's, no thetas. Should just be u's. Yeah, there's actually a 1 there. And I have an x dx in the problem. This becomes this.
So you want that?
I want to get rid of the dx and any other variables. Correct.
Okay. Now I'm going to just put 1/4 u is actually u. So they're equal to each other, right? So 1/2. Why is the 1/2?
Square root. Square root means 1/2. Yeah, I could do the radical u, but most likely you're going to go in the next step. Here, I'll just do it. Radical u. And what you're going to do next is you would have changed this to the 1/2 to make it easy on yourself. Now I take the antiderivative.
Now we want to hear that.
Antiderivative. So I add 1. So it becomes u to the 3/2. Multiply by, oh, that's a 4 down here. Multiply by 2 times 3 plus c. Do a little bit of simplifying. That's a 1. That's a 2. So I have u to the 3/2 over 6. The 2 and the 3. See this? Normally you divide by that, right? Since there's a fraction, we multiply by the reciprocal. How do we that? Add 1. Get 3/2. Then I divide by 3/2, but I don't divide by 3/2. I multiply by 2/3. And the 4 was already on the bottom to begin with. And then I just substitute. U means 2x squared plus 1 to the 3/2 all over 6 plus c is my answer.
What a half.
What half?